Okay, so our problem is how many seats could we put around a train of 100 hexagon-shaped tables? Assume exactly one seat can be put on one exposed side of a hexagon. So to solve this problem, we're going to work with 4 hexagon tables instead of 100 and do some multiplication. So as we can see, the inner tables have 4 exposed sides, which represents 4 seats available. And so if we have 100 hexagon tables total, we're going to take these 2 outsides away, and we can see that we'll have 100 minus our 2 outside tables, so we'll have 98 inner tables times 4 seats at each table. And we're going to use partial products to help us figure out this problem. So we'll do 90 times 4 plus 8 times 4, and then 9 plus 8 is 98, so that works. So 90 times 4 is 360 plus 8 times 4, which is 32. So 360 plus 32 gives us 392 seats available for the inner tables. And then if we add our end tables, we can see that there are 5 exposed seats and 2 tables. So we'll do 5 exposed seats times 2 tables gives us 10 seats available. And if we add that to our existing 392 seats, we will have 402 seats total available. Good. Okay, so another way to solve this problem is to start with a train of 10 hexagon-shaped tables. And I wanted to start with 10 because we know we have 100 total, and then we can multiply however many seats here by 10, which is pretty easy to do to find our total amount. So as we can see, we have our 2 end tables, and then that leaves us with 8 inner tables with 4 exposed seats each. So we'll do 8 tables times 4 exposed seats gives us 32 seats, and then we have our 5 exposed seats on our end tables. So we have 5 seats times 2 tables, which gives us 10 seats. So if we add those together, we will have 42 seats in our 10 hexagon tables. So, but before we multiply, we're going to subtract off these 2 ends, and then we're just going to add them on at the very end. So this way our tables can grow all the way down, and then we'll add our 2. So we'll do 42 minus 2. So we have 40 seats, and then we're going to multiply our 40 seats times 10, that would give us 100 originally hexagon-shaped tables. So 400 seats will be available there, and then we're going to add back our 2 very end seats, which will give us 402 available seats. Okay, so the problem is 170 students need to be transported on buses to a field trip. If each bus holds 35 students, how many buses will be needed? To do this problem, we'll first write down there's 170 students, and each bus can hold 35 students. All right, so that's our little key, and we're going to use a number line to help us out. So to start, we go 35 students per bus, so we're going to go 0 plus 35, so we'll start with 35. So this is 1 bus, and then obviously we need more because we need to reach 170 students. So 35 plus 35 is 70, so we'll go up to 70. And that'd be 2 buses, but that's still not enough. So 70 plus another bus, which is 35 students, gives us 105, which is bus number 3. Still not enough, so we'll add another bus of 35 students, which gives us 140, which is still not enough after 4 buses. So 140 plus another bus will give us 175. And since we only needed for 170 students and we have 175 students, we will have 1, 2, 3, 4, 5 buses required. Okay, so another way to solve this problem of 170 students needed to be transferred in buses that can hold 35 students per bus is to use a mix of props and the scaffolding method. So what we're going to do is have each square represent 5 students. So to see how many squares we're going to start with, we're going to do 170 divided by 5 to see how many squares total we would need. And to do this, we are going to use the scaffolding method. So 5 times 1 is 5, 5 times 2 is 10, 5 times 4 is 20, and 5 times 10 is 50. So since we know 5 times 10 is 50, we can put a 10 here and our 50 here. And so that will leave us with 120. And then we'll add another 10, subtract another 50 to leave us with 70. Still not there, so add another 10, subtract another 50 till we have 20, and then we'll find our 20 here. So it'd be 5 times 4. So we have 10 plus 10 plus 10 plus 4, which gives us 34. So we know that 5 times 34 is 170. And this is important because we have 5 students per square, and we need 34 squares to give us 170 students. So here we have 34 squares representing all of our students, and our next task is to see how many students would fit in the buses. Okay, so next what we would need to do is 5 students per square times how many squares would give us our 35 students per bus. And to do that, we would do 35 divided by 5, which is 7. So with this, we know that 7 squares of 5 students would give us 35 students, which is 1 bus. So we would divide this up 1, 2, 3, 4, 5, 6, 7. So there's 1 bus. 1, 2, 3, 4, 5, 6, 7. 2 buses. 1, 2, 3, 4, 5, 6, 7. 3 buses. 1, 2, 3, 4, 5, 6, 7. 4 buses. And then we don't have 7, but we still need to fit these students onto a bus, so we'll put these into a bus even though it's only 30 students instead of 35. So total we would have 1, 2, 3, 4, 5 buses. Go ahead. Okay, so another way to solve 572 plus 239 is by using base 10 blocks and regrouping. So we'll start with the 1 spot and add 9 to our 2, which is 11. And since we have 10 ones, we can trade that out equally for 1 tens block. And then over in our problem here, that's how we write 11. We put 1 in the tens and then 1 in the 1 spot. And then next we'll add the 70, but now 80 to 30. So we'll bring in 3 tens blocks. And since 10 tens equal 1 100 block, we can switch those out. So now we have 110. So we put the 100 in the 100s and then a 110 in the tens. And now we add 500, now 600 to 200. So we bring in 200 blocks. And that gives us 1, 2, 3, 4, 5, 6, 7, 800. So altogether we have $811. Okay, so in this problem, Lena has $572 in her bank account. So we start with $572, and then she deposits a check for $239. So that means we're adding $239. And how much did she have in her bank account after the deposit? So how we're going to do this problem is break it up by partial sums. So that means we're going to break it up by the place values and add each place value to itself. So we'll start with the hundreds. So we have 500 plus 200. And then for the tens, we have 7 tens, which is 70, plus 3 tens, which is 30. And then the ones, we have 2 plus 9. So 500 plus 200, we mush those together, we get 700. 70 plus 30 is 100, and since 10 tens is equivalent to 100, we can switch that out for a 100 block. And then we add 2 and 9, which is 11. And so we can switch 10 of these out for a tens block. And so if we add all of these together, we get 811. Okay, Martha's granola recipe calls for 1.5 cups of oats per batch. Today she is making a lot of granola, 2.5 batches. How many cups of oats will she need? So we have down 1.5 cups per batch, and we need 2.5 batches. So we're going to use fraction bars to solve this. So we're just going to start by drawing that 1 fraction bar equals 1. And then half of 1 fraction bar is a half. And then if we divide it up into 4, so that is 1/4. And then as we can see here, since this is 1/2, this would also be 1/2, but it's 2/4. So we know 1/2 equals 2/4, and that will help us out later on. Okay, so we're gonna start over here. So if 1 batch is 1.5 cups, we have 1.5 cups. So that's batch number 1, and then we'll add another. We have this half here and that one, so that's another 1.5, so that's batch number 2. And then since we only need 1/2 batches to complete it, we're gonna use our fourths, and it's gonna be 3/4, because as we can see, if we divide this up into fourths, we have 1, 2, 3, 4, 5, 6/4 is 1 batch, and half of 6 is 3. So we would use 3/4 to complete the last half batch. So we have 1.5 plus 1.5 plus 3/4, and that will give us 1, 2, 3, and 3/4. Okay, so another way to solve this problem is by using a number line and adding up the amount of cups per batch. So to start off, for 1 batch, we have 1.5 cups on our number line. And then for our second batch, we go up another 1.5. So that's 2 batches. And then we need 2.5, but we're gonna go up to 3 batches. And then what we're going to do on the third batch is we're going to divide it in half because we need 2.5. So between 2 and 3 is 2.5. So we're going to shimmy down right there between 3.5 and 4. And we know that's 3/4. So we have the amounts of cups per batch is 1, 2, 3, and 3/4 cups will get us 2.5 batches.
When you talk, all I hear is wah, 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 wah.
Are you recording? Dude, I'm thinking. No. Come on.
We love Ed Studies.
Oh my god.
Krista, we're dying.
This is so hard.
We cannot be teachers. Don't let us.
It's 140. We can put our 4 here. I hate you! I hate you! You started laughing. I was doing so good.
Jenny, you are a princess.